So here's the population, a graph of the population of the resident killer whales in the local area. And we're going to do some calculations on this graph, but first we want to ask, what is the scale of the vertical axis? So the vertical axis is the axis that goes up and down, and it goes up by 20s. So 20 what? 20 whales. It says the number of whales on the vertical axis. What is the horizontal scale? Well, each tick is a spread of 5 years. Describe the graph. The graph looks like there is a slight increase in the 80s, a slight increase in the number of whales between 1985 and 1995. It reaches its max in 1995. It's the peak of 100 whales. Maximum number of whales is 100 in 1995, and then after that it starts to decline or decrease. Number of whales decreases between 1995 and the year 2000. So let's take a look at this orca population between 1985, where it has a population of about 70, and 1995, where it has a population of 100. So the numbers might be slightly different because we're estimating from the graph, but they shouldn't be too far off. So the percentage change is the new value minus the old value divided by the old value times 100. So it's 100 minus 70 divided by 70 times 100, which works out to be 0.428 times 100, or 42.8%, and if we're going to round that, it'll be 43%. But that's 43% in 10 years. We want the annual, so per year. So annually, that means we're going to take the 43% and divide it by 10 years to get a 4.3% increase on average per year. Let's do that again now for the second problem, where we take a look at from 1995 to 2000. In 2000, it looks like it was just below 80. So let's make it 79. That's an estimate. So the percentage change is the new value, which is 79, minus the old value of 100 divided by 100 times 100. That equals 21%. Now that is in 5 years. So in 1 year, this is over 5 years, and actually that's negative 21%, sorry. Then in 5 years, it's negative 21% divided by 5 years, which is negative 4.2%. So this represents a decrease, because it's going down, of 4.2% per year.